Alright, your basic hydraulic system. This is subcourse AL0926 Edition A. Basic hydraulic systems and components. Army Institute Professional Development. Basic hydraulic system components. Subcourse number AL0926. U.S. Aviation Logistics School, Fort Eustis, Virginia. 4 credit hours. Edited edition. Date September 1994. Alright, this subcourse is designed to provide instruction for the concept and operation of the basic components for the hydraulic system, and also describe the various components of the typical hydraulic system, their construction functions, and their relationships to each other. While the term hydraulic is applied with the aircraft, it means the needing method of transmitting power from one location to another through used confined fluid. The function performed in the hydraulic system aircraft, including assisting flight control, extending, retracting, landing gear position flaps, operation, hoist, rises, lowering cargo doors, starting engines. Hydraulic system used in the Army aircraft dependent on relatively trouble-free maintenance requirements done in small comparison to the work with such performs. Alright, subcourse review, terminal learning objective, administrative instruction, grading certification instructions. Lesson 1, hydraulic reservoirs, filter pumps, accumulators, motors, and practice exercise and answer key feedback. Lesson 2, basic construction, operation, hydraulic actuating device, flow control, directional devices. Lesson 3, hydraulic pressure limiting control and sensing devices. And then they all have practice exercises and answer keys and feedback. With an examination, appendix, and a glossary, student inquiry sheets, grade certification. Lesson 1, hydraulic reservoir, filter pumps, accumulators, and motors. This lesson will learn the basic operation, hydraulic reservoir, filter, motors, and accumulators of this motor. And introduction. Meaning storing hydraulic fluid to minimize the contamination necessary to any of the aircraft hydraulic system. The feature functions are performed with the reservoir and filters, component which cause the fluid and flow with the hydraulic system. In the heart of the hydraulic system, a hand pump, power-driven pump, accumulator combination of the three. Finally, a means of converting hydraulic pressure to mechanical motion, sometimes necessary, then accomplished by a hydraulic motor. Hydraulic reservoirs. A hydraulic reservoir is a container to holding fluid required to supply systems, including reservoir, to cover any loss of the final leakage and evaporation. Reservoir can be designed to provide space for fluid expansion, permit air entered into the fluid to escape, and help cool the fluid. Figure 1.1 show the two typical reservoirs compared to the two reservoirs item by item, except for the filters and bypass valve, no similarities. Filling the reservoir with the top during surfacing leaves no space for expansion. Most reservoirs designed with a rim of the filler neck below the top of the reservoir to prevent overfilling. Some means of checking the fluid level is usually provided on a reservoir. This may be with a glass or plastic site with a gauge of tube or dipstick. Hydraulic reservoirs are either vented with the atmosphere, closed with the atmosphere, pressurized. Description of each type of the flows. The type is follows. Vented reservoir. Vented reservoir is one that open with the atmospheric pressure with through a vent line with the atmospheric pressure, the gravity of the force which causes the fluid to flow through the pump. And vented reservoir is mounted with the highest point in hydraulic system, and air is drawn into the exhaust through the reservoir from the vent line. A filter is usually installed in the vent line to prevent foreign material from being taken into the system. Pressurized reservoir. Pressurized reservoir is sealed from the atmosphere. The reservoir is pressurized either by engine bleeding air or hydraulic pressure produced with the hydraulic system itself. Pressurized reservoir used in aircraft intended for the high altitude flight where atmospheric pressure is not enough to cause fluid flow to the pump. In reservoirs, pressure, engine bleeding air, the amount of air pressure is determined by an air pressure regulator, usually 10 to 15 pounds per square inch. An example of hydraulically pressurized reservoirs are used in the CH-47 hydraulic system shown in figure 4.1.2. The reservoir tank of the referred to the Boeing Vortol, constructed with a metal housing, 2 internal pistons, 1 fixed, for the other and the other floating piston, which slides into the central tube. Attached floating pistons is larger, that protects the forward end of the tank and is calibrated to indicate full and refill fluid levels for ramp up and ramp down positions. Our typical figure of 1, typical hydraulic reservoirs, aircraft inline reservoir, shows the filler cap, neck fastener, finger strainer, connection for vent line, pressurizing line, glass gauge site, connection for return line, connection for main system air piping, and connection for connection for emergency system pump. On the other side, she's an aircraft inline reservoir equipped with a filter elements and bypass valve. Shows the vent filter element, and then the fins, fluid entering element, wall of the element, bypass valve. Alright, this one's got, hydraulic fluid is at 3,000 psi flow for the central tube shown in figure 1-2. Past the through two outlet holds, air applies pressure at the piston area between two tubes. Because of the smaller piston has a half-inch square inch exposed surface, the floating piston has a 30 square inch exposed surface with 3,000 pounds. Pressure acting on a smaller forward area produces the opposing pressure. 50 psi return fluid stored at rear of the piston. Additional reservoir components. Main reservoir shown in figure 1-1. Many reserves are shown in figure 1-1 and constructed with the baffles and fins to keep the fluid from swirling and foaming. Foaming can cause air to become entrapped and trained into the system. Filters are incorporated in some reservoirs to filter the fluid before it leaves the reservoir. Bypass valve used to enter some of the pump does not start if the filter becomes clogged. A standpipe is used to the reservoir which supplies the normal emergency system. The main system draws in fluid standpipe from the standpipe, which is located with a higher elevation, ensures an adequate fluid supply. Secondary system and the main system. So here's your hydraulic reservoir pressurized with the hydraulic fluid. Shows the housing end of the tube, your fluid and cavity, air, atmospheric air strainer, forward end, fluid to pump inlet fluid, supply fluid, housing, piston, 30 square inches, 30 surface. Alright, 1-2 shows your hydraulic reservoir pressurized in a hydraulic fluid. Hydraulic filter. Contaminating hydraulic fluid is one of the common causes of the hydraulic system troubles installing filter units. Pressurized return line hydraulic system allows contamination to be removed from the fluid before it reaches the various operating components. Filters are type of is referred to line filters. Your line filter construction. Typical line filters shown in figure 1-3. The two major parts of the filter case of the bowl and the filter head of the bowl holds the head the screws into. The head has an inlet port, outlet port, relief valve. The normal fluid flow is through the inlet port and the outside of the element with the through element of the inner chamber and out through the outlet port. Bypass the valve and the fluid passes filter element and becomes clogged. Shows typical line filter. Shows the head with the bypass valve, valving devices, spring and retainer, filter element, O-ring gasket element to head, O-ring gasket to head, and bowl, backup ring, body to body. Shows the inlet and outlet port and bypass valve, filter element, spring and against collapse element. Alright, type of filter elements. The most common filter element used in the Army aircraft is the micronic type. The disposable unit may be treated with the cellulose form of the accordion pleats as shown in figure 1-3. Most filter elements are capable of removing contaminants larger than 20 to 25 microns or 4/1000th of an inch. A type is any other type of the canoe filter that has stacked closely spaced disc shaped like spoked wheels. The hydraulic filter is and passes between the disc. Hand-operated hydraulic pump. The heart of the hydraulic system pump converts the mechanical injury to hydraulic energy. The source of the mechanical injury by any electric motor of the engine or operator muscle. Pumps are powered by muscle called hand pumps. They use emergency backup power pumps and ground checks for the hydraulic systems. Double action hand pump provides fluid from every stroke of the only type of the Army aircraft. Alright, handle to the right. Double action hand pump shown in figure 1-4 consists of the cylinder piston, built-in check valve, piston rod, operating handle, check valve built into the inlet port. As the handle moves to the right, the piston and rod also move to the right. On this stroke, the inlet check valve opens, result of the partial vacuum causes movement of the piston, allowing the fluid to be drawn with the left chamber. At the same time, the inner check valve closes as the piston moves to the right, and the fluid in the right chamber forces into the system. Figure 1-4 shows a double action hand pump starting at the top, going from right to left or clockwise. You have your inlet port, your piston, your O-ring, your outlet port, and then the O-ring there. And then it shows the operating handle going in and then out, moving the ball on the inlet port down and then out through the outlet port. Handle to the left. When the handle is moved to the left of the piston with the rod assembly also moved to the left, the inlet check valve now closed to the preventing the fluid of the left chamber returning to the reservoir. At the same time, the piston head check valve allowing the fluid to enter the right chamber. Fluid into the system. The pump produces pressure over the both strokes because of the difference between volume between the right and left chambers. Piston rod takes up a good share of the space of the right chamber. Therefore, excess fluid is forced out of the pump into the hydraulic system, creating fluid pressure. All right, pump-driven hydraulic pumps. Pump-driven pumps receive the driving force with external power source, such for the aircraft engine. The force is converted with the engine in the form of fluid pressure. Four basic types of the power-driven hydraulic pumps are gear, vane, diaphragm, and piston. Of these, piston type the most commonly found with the Army aircraft. This reason is for that is most efficient, higher pressure, and longer life than any others. Piston pumps are further categorized either with a constant delivery, variable delivery. Pumps are coupled with two driving units by shorts or spling coupling shafts, commonly called the drive coupling. As shown in Figure 1.5, the shaft is designed with a weakened center of the called the shear section, just enough to strengthen the run of the pump under normal circumstances. Some should trouble the development of the pump, causing the turn unusual hard. The shear section will break. This prevents the damage of the pump-driven driving unit. 1.5 shows the pump driving coupling, shear over the device of shear section over the drive coupling. Constant delivery piston pumps deliver the given quantity of the fluid revolution of the driving coupling regardless of the pressure demands of the quantity of fluid delivered by per minute depends on pump revolutions per minute system requiring constant pressure. The type of the pump must be used with the ratio regulator. These two types of constant delivery piston pumps are Army Craft angular cam. Angular piston pump construction. Basic components of angular piston pumps are shown in Figure 1.6. They are a rotating group consisting of a coupling shaft, universal link connection rods, piston, and cylinder block. A stationary group consisting of the valve plate with the pump case housing. The cylinder boards lie with the parallel are even spaced around the pump axis. For this reason, the piston pump is often referred to as axial piston pump. Packing on the seals required not to control the piston, not required to control the piston to bore leak if the control is entirely with the closing machine. Accurate fit with the piston bore clearance of the only enough to allow the lubrication by hydraulic fluid with a slight expansion when the parts are to be heated. The pumps are individually fitted to their bores during manufacture. Must not be chained with the pump to pump or bore to bore. Pump operations. A couple shaft that's turned with the power pump. The pump power source for the piston of the cylinder turn along with they are interconnected. The angle that exists between the cylinder block with the coupling shaft causes the piston to move back and forth in the respective cylinder bores as coupling in the turn. During the first half of the revolution, pump the cylinder is also aligned with the inlet port with the valve plate with the time of the piston moving away with the valve plate withdrawing with the hydraulic fluid into the cylinder. During the second half of the revolution, cylinder is lining up with the outlet port and the valve plate. At this time, the piston is moving toward the valve plate and causing a fluid previously drawn within the cylinder force but out through the outlet port. Fluid is constantly being drawn into the expelled out of the pump. This turn that provides multiple overlap of the individual spurts of fluid force from the cylinders result with delivery smooth and non-pulsating flow of fluid from the pump. Cam pistons, pumps. A cam is usually the cause of the stroking piston in a cam piston pump. Two variations. Usually the one cam rotates, cylinder block is stationary. The other cam is stationary and the cylinder block rotates. Both cam piston pumps are described below. Shows the pump case stationary, and then it shows cylinder bearing in your valve plate, and then it shows a typical angular piston, seal coupling shaft, radial bearing, outlet drain port, driving shaft plate, radial bearing, universal linkage piston, cylinder valve plate, inlet port, outlet plate, piston, connection rods. Rotating cam pump. The rotating cam pump is the most commonly used by the Army aviation. Also, cam turns the rotating cam pump as high as low points pass alternately turn around each piston. It pushes the piston further into the bore with the causing fluid to expel with the bore, while the falling face for the cam under the piston returns spring pulls the piston down over the bore, causes fluid withdrawn into the bore. Each bore check valve opens to allow fluid to expel with the bore with the piston movement. The valves are closed with a spring pressure inlet the stroke of the piston. Fluid is drawn with the bores only through the central inlet passages. The bores only through the center inlet passages. The movement of the piston drawn in with the expelling fluid is overlapping result of the non-pulsating fluid. So here shows your oil seal, the internal spleen, your drainage recess, your drain port, drive shaft, drive shaft and cam, and springs. And then it has a check valve and a pressure annulus piston, inlet, intake, and outlet. Or your stationary cam pump. The operating construction stationary pump is identical with the rotating except for the cylinder block turns nor the cam. The stationary cam pump is not used for the Army OV1H1G and UH1C. Variable delivery piston pumps. Variable delivery piston pump automatically instantly varies the amount of fluid delivered with the pressure circuit with the hydraulic system, meeting varying system demands. The accomplished using the compensator, which is an integral part of the pump. The compensator is sensitive to the amount of the pressure present in the pump. The hydraulic system pressure circuit. The circuit pressure for the rise of the compensator cover the pump out to decrease. Conversely, when the circuit pressure drops, the compensating cover the pump output to increase. There are two ways of varying output: demand principle, cam, and stroke reduction principle. Angular demand principle. The demand principle in Figure 1.8 is based on varying pump output filled with a system changing the demands of the making the piston stroke every varying degree. Figure 1.8 shows the variable delivery demand principle cap, drive cam, and then your intake relief holes, and your piston sleeve, compensator piston, control orifice, and then discharge and compensator spring. The pistons of the design with a large hollow center, with the centers are instructed with the cross drill with the relief valve holes that open with the pump case. Each piston is equipped with a movable sleeve, which can blow through block the relief holes. These holes are blocked with an display for the piston with the discharge through the relief holes of the pump casing with instead of the pump the check valve with the outlet port with the fluid flow for the required sleeve of the piston blocking with the relief holes for the entire length of the piston stroke. The zero flow with the required sleeve of the position but not to block during flow during any portion of the piston stroke required with between zero and full flow. Relief valves are uncovered and blocked. Accordingly, sleeves are moved into required position. Device pump of the pumps, compensator piston sleeve of the compensator piston are interjected with the means the spider. The fluid pressure of the compensator piston is obtained with a discharge port system pressure through a control orifice. Stroke reduction principle. The stroke reduction principle in Figure 1.9 is based on varying angle of the cylinder block angular pump. The control length of the piston stroke, thus the volume per stroke. The cylinder block angle change with the achieved with using the yoke swivel around the pivot pin call of the pinlet. The angle of the automatically controlled U for the compensator, assembling with the consisting of the pressure control valve, pressure control piston, mechanical linkage connected to the yoke. A system pressure increase for the pilot valve open passageway, allowing the fluid to contact control piston. The piston move the compressing ring through the mechanical linkage, move the yoke toward the zero flow and zero angle piston. The system pressure decrease the pressure is relieved the piston, and the spring moves the piston, move the pump into full flow position. Hydraulic accumulators. The purpose of the hydraulic accumulators is to store hydraulic fluid under pressure. This may be used to dampen the hydraulic shock with the development of the pressure surge that occur in hydraulic systems. Add to output of the pump during leak to operation of the system, making it possible to use the pump with smaller capacity than would otherwise be required. Absorb the increase of fluid volume caused by the increase of temperature. Acts as a source of fluid pressure, starting aircraft auxiliary power units and assist in the emergency operation. Alright, this shows variable stroke reduction pump, shows the zero flow, and then it shows full flow. And 1 would be your pressure outlet line, 2 passageway, 3 valve plate, 4 block assembly, 5 yoke, 6 bearing, 7 drive shaft, 8 pintle, 9 piston, 10 piston opening, and then 11 pressure control, 1 pressure control piston, 12 adjusting screw, 13 pilot valve, 14 pressure control valve. Accumulators are divided in types according with the means to separate with the air fluid chamber. These diaphragm, bladder, and piston accumulators. Diaphragm and frame accumulator. Diaphragm accumulator consists of 2 hollow hemispherical metal sections, both of the 2 at its center. Notice the Figure 110, 1/2 has fittings at each of the unit with the hydraulic system. Other half is equipped with the air valve with charging the unit with the compressed air into the nitrogen bound between the 2 halves. The synthetic rubber diaphragm that provides accumulator in 2-section. Accumulator initially charged for the air through the air valve with the pressure approximately 50% of the hydraulic system pressure. The initial air charge forces the diaphragm upwards against the inner surface of the upper section accumulator. So this is system pressure and air valve of the diaphragm accumulator. When fluid pressure increases, the initial air charged fluid is forced into the upper chamber. So the air valve and the system pressure. Um, so your diaphragm accumulator will fill your pistons, keeps the pressure in the bottle. Pressure port. Pushing the diaphragm down further, compressing with the air, bottom charge of the under peak lobe with the air pressure low chamber with the force of the fluid back of the hydraulic system. Limited amount of pressurized fluid into the system. Your bladder accumulator operates the same principle for the same with the purpose of the diaphragm accumulator with a very construction figure 111 unit with the one-piece metal sphere with the fluid head pressure inlet in the top of the opening with the bottom with the inserting of the bladder. Large screw type of the plug with the bottom of the accumulator retains in the bladder. As a seal unit with a high pressure air valve is also incorporated with a return plug with the fluid entry through the system pressure port. Fluid pressure increases above the initial air charge of the accumulator and forces the bladder downward against the pressure. So it has system air pressure and then the screw and the plug and the air valve. Charging fluid with an upper chamber with the fluid pressure. The broken lines figure 111 indicate approximate position of the bladder at the time of the initial charge. Piston accumulator. Piston accumulator serve for the same purpose, operates the same principle of the diaphragm bladder accumulator, shown figure 112 within the unit of the cylinder pressure piston assembly with the ports on each end of the fluid pressure of the system enters the left of the port, forcing the piston down against the initial air charge. Right chamber of the cylinder, high pressure air valve located on the right port of the charging unit. Drill past the fluid side of the piston, outside of the piston provides lubrication with the cylinder walls and piston. So this shows your fluid pressure, some fluid present, pressure present, and then drilled passages eliminating hydraulic lock between O-rings and the air pressure. So this is your piston accumulator. Alright, hydraulic motors are installed with a hydraulic system. The hydraulic pressure obtained with the power with the rotation hydraulic motors does just the opposite of the power-driven pump goes. The pump receives the rotative force of the engine. Other driven unit converts to the hydraulic pressure. A hydraulic motor receives the hydraulic fluid pressure, converts it into the rotating force. Figure 1.3, a typical hydraulic motor, two main ports through the fluid pressure is a receive and return fluid with the discharge marked A and B, respectively. Motor of the cylinder, block and piston assembly with the bores and piston arrangement, same as in a hydraulic pump. The hydraulic motors can easily be started, stopped, and then reversed under any degree of load. They can be stalled by overload without damage. Direction rotation hydraulic motor can be changed by reversing flow of fluid into the ports of the motor. Typical 113 shows the typical hydraulic motor, a bypass cooling lubricant in port A and port B. Summary: the basic components of any hydraulic reservoir, pit filter, pumps, and hand or power driven. The reservoir holds the fluid supply with the system, helps cool fluid. Filters are used to ensure that no contamination reaches the components of the hydraulic system. The repeated micronic filter is the most common. Pump converts mechanical energy to fluid flow. The most common power-driven pump is the piston pump. Also, the simplest hydraulic system varied delivery pumps are used. The variable delivery pumps delivers the amount of fluid in demand by the system accomplished through the user of the compensator. Depending on the type of the aircraft, hydraulic accumulators, hydraulic motors can be used to found within this system. Accumulators used primarily to supply pressure to starting auxiliary power units in emergency hydraulic pressure. Hydraulic pressure motors perform various functions, including raising and lowering cargo doors, operating rescue hoists, and piston wind flaps. This page is intentionally left blank. Lesson 1, practice question exercises. This page is intentionally left blank. It has more practice questions. Lesson 1, practice answer keys. Alright, lesson 2, basic construction operation of hydraulic actuating device, flow control, and direction valves. Directional valve devices.